NOV's Spring It Technology Center here in Navasota, Texas, played host to a work session being held as part of ongoing efforts to upgrade IADC's drill bit dull grading code. The code has been an industry standard since the late 1980s, and a work group led by the IADC Advanced Rig Technology Committee is looking to help bring it into the modern age. This work session provided an opportunity for subject matter experts to physically inspect drill bits with the new code and provide their feedback on what's going well and what still needs to be improved. The work session is part of a project that was launched last year to update IADC's bit dull grading system for the first time in 35 years. Paul Pastuzik, drilling mechanics advisor at ExxonMobil and one of the leaders of the ART committee work group spearheading this project, said the update has focused on providing the granularity on the types of damage experienced so that detailed root cause analysis can be conducted.
First off, we used to segment the drill bit into the inner 2/3 of the diameter and the outer 1/3, and that is nowhere near adequate. We've now gone to cone, nose, shoulder, and gauge. That's much more descriptive of the parts of the drill bit that we see that are damaged, and it helps us to identify where the root cause is coming from. So for me, that's one of the really big ones. The other is that we've got some types of fracture damage and things that are occurring that we didn't classify before and that are very important. And one of the ones that I really love to point out is like tangential fracture. It's back through the carbide and the diamond table, and we didn't distinguish that in the past. So that's a very, very distinctive type of fracture, and it has a very distinctive cause that we can do something about. The work group is seeking to develop a qualitative classification scheme of PDC cutters, drill bits, and tools with cutting elements. The updated code introduces new categories such as chamfer damage and axial break, as well as a category of classes designed to evaluate the wear on the substrates of PDC cutters. The work session, which took place on July 20th, allowed SMEs to physically evaluate drill bits with varying degrees of wear using the updated code for the first time. This particular work session is on the drill bit side. This is the first time I've known that we've ever gotten the entire group of SMEs together, or even a large portion of SMEs together, to look at forensics workshop. So this is one step in that chain to get us to the new upgrade. The upgraded system will also provide a framework for the incorporation of automated machine grading systems, some of which were demonstrated at the work session. Tom Roberts, Vice President, PDC Strategy and Development at NOV, said that machine grading systems will be critical to the industry moving forward, and that it was important for the upgraded bit dull grading system to account for them.
The machine grading systems have been around for a couple of years now, and they're all getting better and better. And I wouldn't say it's 5 or 10 years off. I would say they're very close in terms of the refinements to get it, maybe in the next 1 or 2 years. You will have systems that will take away the human factor of having to assess each individual cutter, but have a system that automatically grades the cutter, whether it's done with lasers or photography and so on. So we thought it was important today to get a flavor of how far those systems have come and where they're at.
This work session is focusing on just one part of the upgrade effort, the drill bit code definitions. Mr. Pastuzik said the work group will evaluate the feedback gathered from this work session and work from the other sections of the upgrade effort, such as BHA and motors code definitions, case studies, and data management, in the coming months. The work group will measure the consistency of SME opinions on the new code and see what further adjustments need to be made, with the hopes of having a finished product ready for the industry by the end of the year. The recognition is that we've got digital cameras, we've got image recognition, we've got capabilities that we didn't have before, and we're running PDC drill bits today in 95% of the footage drilled. So there's a range of applications that didn't exist then, and we need to upgrade to be able to do that. The key things, I think, are to be able to incorporate forensics data as part of the workflow so that we get to the root cause at a higher level. It's to be able to get rid of some of the ambiguity, because if you look at the changes that have happened, there's a lot of confusion in the industry of how to grade something today. After a day of testing, the SMEs were optimistic of the upgrades they've seen.
we're obviously not at a finished product, which is why we're here today doing these trials. But I think there is a broad understanding and broad agreement that obviously we needed an improvement. And we've got a lot of people here that are very passionate about bringing that improvement through to fruition to a final product. And there's still work to be done, but we've already established some guidelines that are showing a lot of promise here today. We're getting a lot of positive feedback. Still work to be done, but ultimately it's all about empowering the industry to make better decisions. We, as drill bit, we're a drill bit provider, but obviously our customers being operators, every one of us is there to do a job, and a lot of that job involves making decisions. We need to make decisions based off of good quality data.
Now, it's not too late for you to provide your feedback on this project. If you want to get involved, please email the email addresses listed here. From NOV's Springett Technology Center in Navasota, this is Stephen Whitfield. Thank you for visiting Drilling Contractor.